Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhanis Najihah binti Ibrahim. My batch number is 192523. I'm a final year student of Bachelor of Process and Food Engineering. So today I will present about my final year project, which entitled Evaluation of Tableted Food Supplement Strength and its relationship with compaction pressure. So this presentation will cover introduction, problem statement, objective, methodology, result and discussion, conclusion, and recommendation. So for introduction, compression is also known as reduction in the bulk volume of materials due to the closer packing of powder particles when external mechanical forces is applied. During tableting, few phenomena will occur, which is escaping of air from within powder bed, rearrangement of particles, mechanical interlocking, particle breakage, and deformation. All of these will lead to increases of contact surface, where interparticle bridge may be generated due to enhanced van der Waals attraction between particles. Next, the effect of compaction pressure on tensile strength. The tablet form requires a certain amount of applied pressure, which will increase the interparticle bonding. This will form a strong bond that increases the mechanical strength of tablet at high compaction pressure. The tablet strength is defined as force required to break the tablet. The stronger the tablets, the more force and energy required to break them. As shown in the figure 3 is the schematic illustration of diametrical compression test. Next, for properties analysis, moisture affects the flowability and it depends on the amount of water in its distribution. Flowability decreases when interparticle liquid bridges form are stronger, which increase the cohesion between the particles. Moisture content may affect the tablet's hardness, as it is said to have impact on compression characteristics and mechanical strength. Next, figure shows the flowability character of powder based on Hausner ratio, Carr's index, and angle of repose value. For the problem statement in this study, the tablet manufacturer must be mechanically strong to withstand further processing which measured by tensile strength. To produce a stronger tablet, the relation of compaction pressure and tensile strength is evaluated by correlation analysis. Physical properties of powder also affect the mechanical behavior of powder under compaction. So by analyzing these two, which is the relation of compaction pressure and tensile strength, and the physical properties of powder, the compaction pressure of stronger tablet can be estimated. So the objective of this study is to analyze the properties of simple powder, to evaluate the strength of a tablet by analyzing its tensile strength, and to correlate compaction pressure with tablet's mechanical strength using statistical analysis, and to be compared with literature data available for other food tablets. So the methodology involved in this project is starting from sample preparation, which use food supplement powder as samples with different types of flavor, strawberry flavor powder and chocolate flavor powder. However, the identity of the sample used is restricted due to proprietary reason. And then for powder properties analysis, a few tests were done to analyze the moisture content, bulk, and top densities, and also flowability. The flowability is determined by calculating the Hausner ratio, Carr's index, and angle of repose value. And then for the tensile strength analysis is done by indirect Brazilian test using universal testing instrument machine. And last but not least is the correlation of compaction pressure and tensile strength. This uses two types of correlation method, which is Pearson correlation and linear regression analysis. Next, for result and discussion. So these two tables shows the summary result of tensile strength of powder samples and also summary result of powder properties analysis. And then the graph is shown in figure 10 is the moisture content analysis for strawberry and chocolate flavor powder. Based on the graphs, we can see that strawberry has higher value for both moisture content and also for flowability analysis, which is described in table 4. Meanwhile, strawberry flavor has higher value for both properties analysis and tensile strength. Next is for tensile strength analysis, as shown in figure 11, the tensile strength curve against compaction pressure. We can see from the graph that strawberry flavor has higher tensile strength values compared to chocolate flavor sample. And for both samples, the tensile strength increase at compaction increase. And the highest tensile strength and the highest compaction pressure, which is 67.8 megapascal. And next graph shows the pressure work against compaction pressure. As we know that the higher the tensile strength, the higher energy required to break the tablet, so higher fracture work will require. So we can see that strawberry flavor has higher value of fracture work compared to chocolate flavor, which corresponding to the tensile strength values. And fracture work also increase as compaction increase because it is correlated. Then for correlation of compaction pressure and tensile strength, you can see in figure 14 shows the correlation coefficient versus supplement samples. So between strawberry flavor and chocolate flavor sample, chocolate flavor has higher correlation coefficient compared to strawberry flavor. As we can see, it's quite different from the tensile strength and fracture work values. However, as we know that correlation is correlated to the relationship between tensile strength and compaction pressure. And then for the graph shown in figure 13 is the correlation coefficient of samples with compared available food powders, specifically fructose, maltose, and lactose. So from the graph, you can see that the highest samples that has the highest correlation coefficient is the 0 and 80% maltose, while the lowest correlation coefficient is for the 100% fructose. So in conclusion, properties of powder did affected the tensile strength of tablet, as tensile strength increased when moisture content and flowability increased. The higher tensile strength gives stronger compression of tablet, and tensile strength is highly correlated with compression pressure applied during compression as tensile strength increased when compression pressure increased. As for recommendation, the solution test can be done to ensure the tablets were able to disperse in solution, and also the particle size analysis can also be conducted as particle size contribute as a factor of tablet's mechanical strength. That's all for me. Thank you for watching.